So firstly, I will present on the introduction for single line diagram. Basically, a power system or electrical circuit is simplified in a schematic known as one-line diagram. A single line diagram frequently and often represent each phase in a polyphase system like the three-phase power system used for electrical power distributions. This single line diagram is used to show the key components of the systems. The example of key components that is used for power generations is generator, transformer, switchgear, circuit breaker, and other more.
I will continue the presentation at discussion part. Next, we go to the discussion. The single line diagram show the power generation, transmission, and distribution from a power plant to consumer. The power transmission from a power plant to consumer involve a complex and multi-stage process that involve some components such as power station, transformer, transmission line, substation, distribution, and loads. The diagram illustrates the path of electricity flow. There are two parts of electrical power transmission, that is primary and secondary. First, we go to the primary transmission. At primary transmission, electricity is generated at power plant. The 11 kilovolts voltage will flow through step-up transformer and step up the voltage to 132 kilovolts. The high voltage electricity is then transmitted through a network of transmission line and towers. After that, before reaching to the receiving station, the voltage will be stepped down by a transformer from 132 kilovolts to 33 kilovolts. Then it will reach the receiving substation and at the end of primary transmission. Okay, next we go to the secondary transmission. For the secondary transmission, as the electricity gets closer to consumer, it will come across another transformer and the voltage will be stepped down again from 33 kilovolt to 11 kilovolt and will reach the substation. From the substation, the voltage will go through distribution transformer and step down again from 11 kilovolt to 515 kilovolt. Finally, electricity will reach the consumer and distributed to loads.
Now I would like to continue on our group presentation on the last part, which is the conclusion. So in conclusion, the single line diagram can not only be used as a representation of the system configuration, but it can also act as a dynamic tool for troubleshooting, maintenance optimization, and also can be used for strategic planning in the realm of industrial power system. This versatile functionality makes it an essential resource for electrical engineers. This is because this will help them to navigate the complexity of power generation, transmission, and distribution with efficiency and foresight.
Alright, this is our group overview for the power generation. So our group chose the solar for the power plant generation. As we know, solar is referred to harnessing sunlight for electricity only. It is clean and renewable energy source widely used for power generation. Alright, next we have the power transformer here. Power transformer, as we know as a set-up substation. Set-up substation and electrical power generating plant typically generate a voltage between 2.3 kV and 33 kV. Set-up substation contain high voltage transformer that boost the generator output voltage to the value between 150 kV and 795 kV and provide power output in the thousands of kiloampere and the higher. So the electric gear will transfer to the transmission line. This is transmission tower. So transmission tower is used to transmit electric energy over a relative long distance. And we have transmission substation here. Transmission substations, we call this step down substation. Step down substation to decrease the transmission line voltage down to sub-transmission level and line level, typically between 26 kV and 96 kV. As such, the substations act as the interference between transmission line and sub-transmission line. And after that, we transfer to the distribution substation. Distribution substation is decrease a sub-transmission voltage to customer usable level. As such, there are also step-down substations like other substations. Distribution substations typically contain a lightning arrestor, overload protector circuit breaker, voltage regulator, input-output switching circuit, and a control circuit. And the current will flow to the industrial and the residential.